Okay, so generative AI, it's everywhere you look these days, and for good reason.
Right.
It's changing so much, so quickly.
Yeah. I mean, it can create realistic images,
Mm-hmm.
compelling text,
Hmm.
even functional code.
Yeah. It really seems like it has the potential to be, like, incredibly innovative.
Oh, absolutely.
Huh.
For sure. It's a huge boost to efficiency.
Right. And driving a lot of this progress is this really interesting combination
Right.
of NVIDIA, with their accelerated computing
Yeah.
and AWS with their like robust infrastructure. I know they were talking about this a lot at AWS reInvent last year, 2024.
Yeah, that's right. It was a big focus. It's a
Yeah.
really powerful synergy.
Right. And NVIDIA is well known for their GPUs.
Yeah. Graphics processing units.
Oh, right. But they're doing a lot more than that.
Yeah, they're really branching out, high-speed networking.
Yeah.
And they've built this whole ecosystem of AI software.
Yeah. So it seems like this end-to-end approach
Right.
is really important to get the best performance.
Absolutely.
To scale generative AI workloads.
Yeah. Yeah, especially
Especially with these huge models.
yeah, the large complex ones for sure. It's not, it's not just about throwing more processing power at it.
Mm-hmm.
It's about making sure the power can be used effectively.
Yeah. Like the demands are so specific for these tasks.
Right. Whether it's, training models with like trillions of data points.
Right.
Or running these real-time generative applications.
Right. So for this deep dive, what we really want to do is give you a clear picture of how all of this is working.
Yeah.
Like how NVIDIA's AI tech is integrated within AWS
Right.
for generative AI. And we'll really focus on extracting the most important insights.
Absolutely. Focusing on the signal amidst the noise.
Right.
Well,
So it's a shortcut to being well-informed
that's the goal.
on this rapidly evolving field. So we're going to explore several key areas.
Okay.
First, NVIDIA DGX on AWS.
Uh-huh. The computational engine.
Right, the powerhouse. Then NVIDIA AI Enterprise on the AWS marketplace,
Right.
which has like a whole set of tools, enterprise-grade AI tools.
Yes. Yes.
And then we'll look at NVIDIA NIM on Amazon SageMaker Jumpstart,
Okay.
focusing on how it accelerates deployment of these models.
All right.
And finally, we'll explore NVIDIA NeMo as a platform for building and customizing your own models on AWS.
Right.
So let's start with NVIDIA DGX on AWS.
Okay. Sounds good.
What is it that makes this platform so powerful?
So NVIDIA DGX systems, they're purpose-built AI supercomputing platforms, right?
Okay.
Designed to handle these really demanding deep learning tasks
Uh-huh.
and high-performance computing workloads. Like, this is the foundation of modern AI development.
So is it more than just taking powerful GPUs and just, adding them to a server?
Yeah. Think of it as a machine designed from the ground up,
Okay.
specifically for AI.
Uh-huh.
So it uses the most advanced NVIDIA GPUs, like the H100,
Right.
the H200. And looking ahead, we've got the Blackwell architecture. But that's just one piece, right?
Yeah.
Inside these systems, they're connected using NVLink, which is super high speed.
Okay.
And for connecting multiple DGX systems, they've got InfiniBand or Ethernet.
Right.
And it also has the right CPU and memory configurations, really fine-tuned for AI workloads.
So it's all very integrated and optimized.
It is, yeah. And another key thing is that it comes pre-integrated with NVIDIA's AI software stack.
Okay.
So that includes NVIDIA AI Enterprise, which has tools like NIM, NeMo, and even things like Rapids for accelerated data science.
Right.
This is what allows for such high performance right away.
Yeah, it makes sense. So I've also heard of DGX Cloud on the AWS marketplace.
Right.
What's that about? How does that play into this?
So DGX Cloud, it's making AI supercomputing more accessible through fully managed high-performance compute in the cloud.
Okay.
So organizations can access the infrastructure
Right.
and the software they need to train and deploy these really advanced AI models, the ones with tons of parameters.
Yeah. Right. So let's say someone is trying to train a large language model.
Yeah.
Why would they go with DGX Cloud over just using AWS EC2 instances?
That's a great question. So DGX Cloud, it's a more opinionated solution.
Okay.
It's not just raw computing power.
Right.
It's a platform that's specifically optimized for AI performance, streamlined workflows. It includes that full NVIDIA AI enterprise software stack. So it's a really comprehensive and supported environment for development. Plus, you get access to NVIDIA's AI experts for support.
Yeah, that sounds really useful to be able to just like contact an expert
Yeah.
when you're dealing with, AI at this level.
Especially when you're scaling your AI deployments, right?
Yeah.
Trying to optimize those complex training processes,
Yeah.
it can be a big help.
Right. So what are some of the other advantages of using DGX Cloud?
So another one is that it's focused on reducing the time to first train,
Okay.
getting you up and running quickly with model development and experimentation. And they have flexible commitment options. You can even do like shorter 1-month terms,
Okay.
which can be helpful for startups.
Right.
Or companies that are newer to AI.
Right.
And you get access to the latest GPUs,
Okay.
like the H100 and H200. And they even have plans to support the Blackwell architecture on the EC2 P6 instances,
Okay.
which are coming out.
So security is a big deal, obviously, especially when you're dealing with sensitive data for training.
Right.
So what kind of security measures are in place with DGX Cloud?
Yeah, security is super important. It integrates with the AWS Nitro system.
Okay.
It uses encrypted EFA, which is Elastic Fabric Adapter,
Right.
for secure networking. And the Blackwell architecture has advanced encryption.
Okay.
So it's really strong end-to-end protection.
Okay. That makes sense. What is Project SIBA?
So Project SIBA, that's a really interesting one.
Okay.
It's this massive AI supercomputer built on AWS using DGX Cloud. So it's collaboration between AWS and NVIDIA. And it's going to be NVIDIA's powerhouse for their own AI research and development,
Okay.
really pushing the limits of generative AI.
So they're kind of using their own technology on AWS to further their own innovation.
Right, exactly. It shows you how scalable and powerful it is.
Right.
And if you're doing distributed training, DGX Cloud on AWS supports auto-mounted EFA,
Okay.
which makes it easier to use that high-performance networking.
Right.
And there's an option for private access to the DGX Cloud Run.ai deployment.
Okay.
So you can connect securely within your AWS network.
So who's actually using DGX on AWS right now? What are some of the applications?
There's a lot of different use cases. It's great for training large language models, foundation models,
Right.
the ones that need a lot of computing power. People are also using it to fine-tune pre-trained models with their own data
Okay.
for specific things.
Right.
And it's great for running inference for real-time applications. So things like advanced design.
Simulation. Leonardo.ai, which is part of Canva, they're doing that.
Yeah.
Healthcare, drug discovery. Platforms like BioNemo,
Right.
even big software companies like ServiceNow are using it to train large generative AI models.
So it's being used all over the place.
Yeah, it's pretty broad.
So when you have all this power, how do you make sure you're using it right?
Right. That's where benchmarking is important.
Okay.
So NVIDIA DGX Cloud benchmarking, it gives you tools and guidelines to see how well training and inference are doing
Okay.
across different workloads and platforms. So it looks at the whole stack, from hardware to software.
So it's not just about raw GPU speed.
Exactly. There are a lot of factors.
Okay.
The hardware design, operating system efficiency, virtualization, software optimization, network architecture, storage, the balance between computation and communication.
Right. It's a lot.
Yeah. And then you have to think about model scaling, batch size, and precision format.
Okay.
So using FT8 precision can really speed things up. And save money. And things like Transformer Engine in the Hopper and Blackwell architectures can use reduced precision to optimize speed without losing accuracy.
Wow. So it sounds like NVIDIA is giving people a lot of tools to navigate this stuff.
Yeah, they are.
Okay, let's talk about NVIDIA AI Enterprise on the AWS Marketplace.
Okay.
What's the point of that?
So NVIDIA AI Enterprise, it's a software platform, cloud native.
Okay.
It's all about making data science faster
Okay.
and making it easier to develop and deploy production-ready AI applications,
Right.
including generative AI.
So it's not just a bunch of different software packages.
No, it's designed for enterprises. So you get enterprise-grade support, security, and reliability
Okay.
for these really important AI workloads. NVIDIA releases regular updates and patches
Right.
to fix vulnerabilities, and they have a production branch that guarantees API stability,
Okay.
which is really important for long-term consistency.
Right.
Another big thing is portability.
So your AI applications can run on AWS, private clouds, even on premises.
Yeah, that flexibility is really important.
It is. It reduces risk when you move projects from development to deployment.
Makes sense. What are some of the key components that are in NVIDIA AI Enterprise?
Well, you get NVIDIA NIM and CUDS microservices.
Okay.
Those are optimized runtime environments and pre-built components for generative AI and inference.
Okay.
And you have NVIDIA NeMo, a framework for customizing pre-trained models with your own data.
Right.
For speech AI, there's NVIDIA Riva.
Okay.
It's a GPU-accelerated SDK for multilingual speech and translation. If you want to enhance audio and video with AI, you can use NVIDIA Maxine.
Right.
It can do things like noise cancellation and augmented reality effects.
Wow.
And to get started quickly, they have NVIDIA AI workflows. Those are pre-packaged applications with models, pipelines, and code notebooks.
Right.
And it supports major AI frameworks like PyTorch and TensorFlow, plus NVIDIA tools like Rapids for data science, TAO toolkit for training, TensorAI for optimizing models, and Triton Inference Server for deploying them.
Okay.
They even have industry-specific tools like NVIDIA Claramon AI for medical imaging and Clara Parabricks for genomics.
Okay.
And for large data sets with Apache Spark, there's the Rapids Accelerator.
So you've got basically everything covered.
Pretty much. And importantly, NVIDIA AI Enterprise supports all their software on NGC that's labeled NVIDIA AI Enterprise Supported.
Okay.
And you get access to unencrypted pre-trained models, which is helpful for understanding how they work and speeding up customization.
Right. Okay, how do you actually get started with NVIDIA AI Enterprise? What are the steps?
So you start by searching for NVIDIA AI on the AWS Marketplace.
Okay.
They have different licensing options like hourly, bring your own license, and private offers. You launch it on a GPU-enabled EC2 instance.
Okay.
They support many instances like P4D, P3, G4DN, G5, A100, and H100.
Right.
You configure network and storage. And once it's running, you activate your subscription. You get an instance ID token from the AMI.
Right.
Take it to the NGC portal, activate it, and get an API key. Then you put that key on your instance, and you can access all the resources.
So what are the benefits of using it?
Well, it speeds up your time to production.
Okay.
Because of the optimized tools and workflows. You can improve efficiency and save money.
Right.
Using the optimized software and pre-trained models. You get the enterprise-grade security and reliability.
Right.
Direct access to NVIDIA experts.
Okay.
And that portability we talked about.
So it really helps with deploying and managing AI on AWS.
Yeah, it does.
Okay, let's move on to NVIDIA NIM on Amazon SageMaker Jumpstart.
Okay.
What is NIM and how does it speed up deployment?
So NVIDIA NIM, it's a set of cloud-native microservices made to accelerate deployment, especially at scale. The focus here is on optimized inference, so running the models after they're trained.
So it's about taking those models and actually using them in applications.
Right, exactly.
Okay.
And NIM has several benefits. Security and control, because you're self-hosting on AWS.
Okay.
It reduces engineering effort and cost.
Right.
Because the microservices are pre-built and updated by NVIDIA, developers get the latest models and APIs, which makes integration easier.
Right.
You also get faster response times and higher throughput because it's optimized for low latency.
Okay.
And it's enterprise grade with support from NVIDIA.
Right. So these microservices are now in Amazon SageMaker Jumpstart.
Yeah.
What does that mean for people using SageMaker?
It makes deploying inference workloads really easy.
Okay.
They can find and deploy NVIDIA's inference capabilities with a few clicks in the console or a few lines of code with the SageMaker SDK.
Okay. So it's all about convenience for developers using SageMaker. What kind of models are we talking about here?
There are a lot, and it keeps growing.
Right.
You have Meta's Llama 3, Mistral AI's Mistral and Mixtral,
right?
NVIDIA's Nematron models, and Stability AI's SDXL for images.
Right. So these are all like big names in generative AI.
Yeah, definitely.
Are there any specific ones in Jumpstart you want to talk about?
Yeah, I want to highlight the Nemo Retriever Llama 3.2 Text Embedding EM.
Okay.
And the Nemo Retriever Llama 3.2 Text Re-ranking EM.
Okay.
Those are for question answering and information retrieval.
Right. So first, what does the embedding EM do?
It creates embeddings of text for multilingual question answering retrieval. It can handle long documents, up to 8,192 tokens.
Okay.
And it uses Matryoshka embeddings for a dynamic embedding size.
Right.
And it works with 26 different languages.
Wow.
English, Spanish, French, German, Chinese, Japanese, Arabic, and many more.
Right.
The big advantages are that it uses way less storage.
Okay.
Up to 35 times less.
Wow, that's a lot.
And it's really efficient at processing large data sets.
Right.
So it improves semantic search and information retrieval.
Okay. What about the re-ranking NIM? What does it do?
So it takes a bunch of documents and gives them a score.
Okay.
based on how relevant they are to a search query. It's also fine-tuned for multilingual question answering.
Right.
It supports those long documents, and it works with the same 26 languages.
Okay.
Basically, it makes text retrieval more accurate by reordering the documents based on relevance.
Right.
It's especially helpful when you're getting information from lots of places.
Okay.
It really improves the quality of our RAG pipelines because it makes sure the most relevant info goes to the language model.
Okay.
And you can integrate it with Haystack, which is an open source framework for Argy.
So basically, embedding finds the answers and re-ranking sorts them.
Right, you got it.
Okay, so how does NIMIM make deployment faster on AWS? Like, practically speaking.
Well, the big thing is the pre-built optimized containers.
Okay.
They're ready to go. Developers don't have to spend time on manual configuration. So the whole process is much faster.
Okay, so beyond SageMaker, how does it integrate with AWS?
It integrates really well. So with SageMaker Jumpstart, it's easy to deploy and manage using the console or the SDK.
Okay.
But it also works with Amazon EKS,
Right.
which is for optimized inference at scale using Kubernetes. So you get support for Helm charts, autoscaling with Carpenter,
Right.
horizontal pod autoscaling, and you can use an application load balancer to distribute requests for high availability.
So that EKS integration is important for handling a lot of real-time requests.
Yeah, it is.
Okay, finally, let's talk about NVIDIA NeMo.
Okay.
For building custom models on AWS.
Right.
What does it offer?
So NVIDIA NeMo, it's a framework, end-to-end, for building, customizing, and deploying large-scale generative AI models. This includes large language model, multimodal models, and models for vision and speech AI.
So it's for a lot of different generative AI applications.
Yeah, a wide range. It has functionality for every stage of development, efficient data curation, ways to customize models, support for RAG, and performance optimization.
Okay. So starting with data preparation, what does NeMo have?
For that, you've got NVIDIA NeMo Curator. It's a Python library for fast and scalable dataset preparation.
Okay.
It uses GPUs with Dask and Rapids. It's much faster than CPU-based methods. Has a bunch of features. Downloading data from places like Common Crawl or Wikipedia. Text cleaning and preprocessing. Filtering based on rules and classifiers. Advanced deduplication, even with multilingual support. Generating synthetic data. And tools for downstream task decontamination and removing PII.
Okay, so a lot of tools to get the data ready.
Yeah, and it works with text, images, and video, and it can handle massive data sets.
Okay, so it can really streamline data preparation.
Definitely.
What about customizing the models? What options are there?
So NeMo is really flexible for customization. It supports full fine-tuning, instruction tuning, and prompt tuning. It also supports PEFT methods like LoRa, which let you customize large models with less resources. NVIDIA also has NeMo Customizer. That's a microservice in AI Enterprise for aligning and fine-tuning large language models. And NVIDIA actually worked with Amazon to train Amazon Titan using NeMo.
Oh, wow.
So it's really powerful.
You mentioned RAG before. How does that work in NeMo?
So for RAG, you have NVIDIA NeMo Retriever. It's a set of microservices for building AG pipelines that are accurate and private. So the basic RAG process is indexing your knowledge sources. Embedding the text. Retrieving the most relevant information. And then using that to augment the prompt for the language model. NeMo Retriever has support for high-performance embedding models like EmbedQA E5 V5. And it integrates with NIM for optimized performance and scalable deployment.
So it connects these generative models with external knowledge. How does NeMo use NVIDIA GPUs on AWS to speed things up?
It's designed to take full advantage of the GPUs for both training and inference. It supports multi-GPU and multi-node configurations. So you can do distributed training on EC2 instances. They have a tool called NeMo Run for managing experiments. And it integrates with Amazon SageMaker HyperPod, which is for large-scale training. This reduces training time and optimizes resource usage.
So it's a whole toolkit for custom generative AI models on AWS. So to bring it all together, what would a typical workflow look like?
Okay, so first, you would start with data curation. You would use Nemo Curator on AWS
Uh-huh.
to download, clean, and prepare your data
Okay.
for text, images, or video.
Right.
Then you would select a model
Uh-huh.
from NVIDIA NGC or another hub.
Okay.
You would choose based on your task and requirements.
Right.
Then you would customize it
Uh-huh.
using Nemo on AWS
Okay.
with fine-tuning or other techniques.
Right.
For really large models, you might use SageMaker Hyperpod.
Okay.
If you need external knowledge, you would implement RAG
Uh-huh.
using Nemo Retriever and your data on AWS.
Right.
For deployment, you would use NIM microservices
Okay.
on SageMaker or EKS.
Uh-huh.
And finally, you would monitor and manage everything
Right.
using CloudWatch and SageMaker Model Monitor.
So that lays out all the steps. It's clear NVIDIA is providing a lot for each stage of generative AI.
Yeah, they are.
And all of this is integrated with AWS services, right?
It is, yeah. That's super important for a good experience.
Uh-huh.
So, for example, Amazon SageMaker.
Okay.
SageMaker Jumpstart makes it easy to deploy NIM.
Right.
SageMaker Hyperpod is for training large models with Nemo.
Uh-huh.
SageMaker Inference has different deployment options.
Okay.
And SageMaker Model Monitor tracks model health.
Right. What about if people are using containerization?
Then Amazon EKS is key.
Okay.
It's a platform for deploying NVIDIA-accelerated workloads with Kubernetes,
Uh-huh.
good for scaling NIM inference.
Okay.
EKS manages GPU resources well.
Right.
And you can use Carpenter for auto-scaling
Uh-huh.
and an application load balancer to distribute requests.
So it all works together for high availability.
Exactly.
What about other AWS services?
Well, Amazon S3 is for storing data.
Right.
Amazon EC2 has GPU-accelerated instances.
Uh-huh.
AWS Marketplace is for getting AI Enterprise and NIM.
Okay.
CloudWatch is for monitoring.
Right.
And step functions can orchestrate workflows.
So it sounds like NVIDIA and AWS are really working together
They are.
to make generative AI accessible.
Yeah, definitely.
So as we wrap up, what's the most important takeaway?
I think it's that NVIDIA and AWS together offer a lot of power and flexibility for generative AI.
Okay.
You get faster development, optimized inference, and cost-effective scaling.
Right.
It's the whole package that's really impressive.
Mm-hmm.
The tools, the frameworks, the services, the support.
Right.
It's a strong foundation for anyone working in AI.
And generative AI is still changing so fast.
It is.
So this collaboration is going to be important going forward.
I think so, yeah.
So for our listener, think about what part of this was most interesting to you.
Right.
What could have the biggest impact on your work?
Yeah. What resonates with you?
And we encourage you to look into the resources we talked about.
Absolutely.
There's a lot to explore.
Yeah, definitely.
Thanks for joining us for this deep dive.
Thanks for having me.